Okay, we're recording, so Chris, you can go ahead and get started.
Okay, well, welcome everyone. Thanks for being here. Um, Today we're going to talk about something a little different. We're going to go over some Inventor training, and this coming from someone without very much Inventor experience. But what I do know is that the Seattle group, our sister company, they use Inventor quite a bit. And so they've done a lot of training, and I'm really wanting to make you aware of the training that they've already done and just kind of show you where everything is. So not to be redundant, but let's just go ahead and show you where all this training is stored. So go into our portal, our engineering tab, and then go into training. And then if you scroll down into training content, you'll see this last container is called Inventor Training. And that's where all of these videos that have been created by the Seattle group are stored. So these are what they use for their own training purposes. And so we're going to talk about these, not each one of them in depth, but we're going to talk about what they've got here and a little bit about what the categories are. And then we're going to watch one, and then we'll kind of talk about just a little bit of, if you guys have questions, how we'll handle that too. So first of all, there's one that they use. Well, let me back up for a second. So Seattle uses kind of a hybrid model. They draw what they call wireframes in AutoCAD, and then they use those wireframes paired with the takeoff program so that it can assign mark numbers. From that point, they take those wireframes in AutoCAD and they move that into Inventor, where they can then use that modeling for all of their fabrication drawings. So you can see that it seems, it's just not the method that we're using, and so it seems different to us. But what these all are just Inventor files, so it's not starting with the wireframe creation process. So they have some different categories of their unit assembly process, and there's videos in here. And I'll say that most of these have been created by Ed Stringer. He also has had help from Gabriel Ahern and Alessandro Boraro. And so between the three of them, they've created all of these different trainings. So they have the unit assembly process, and there's two videos on that. There's one on the unit drawing process, and then the unit modeling process. And it's in this unit modeling process that the way Ed described it is you could watch from lesson 1 through lesson 12, and that's going to take you through modeling a unit. But he said you could really take that and extract the information that you've learned by watching those and use that information to try to model anything else. It doesn't have to be a unit the way that they do it. It could be, modeling anything. So it's really that lesson 1 through lesson 12. If you were going to try to learn how to do that, you could watch through those. So we're going to watch one of those videos together. Then iFeatures. In Inventor, iFeatures is something it's sort of almost like a block in AutoCAD. iFeatures allows you to save a part or a collection of conditions that you could reuse later, almost the way that we save notches that will be used for programming over and over. iFeatures can be reused repeatedly. And so if you have, say, a hole pattern or a notch pattern at the bottom of your vertical at a stack joint, you can save that condition in iFeatures and then reuse that repeatedly. And then the last category they have is Vault process. Vault is an Autodesk software that you can get that it's basically a method of checking in and out drawings that as you have a team of people using files together, it's really a way of just understanding where the drawings are, how they're being used, what changes have been made to them. It's a very, you could say, team-friendly software that they pair together with Inventor. And that's if they're using Vault Professional. So it allows them to see all the different changes that happen along the way. So, all right. So just kind of as a way of jumping in, we're going to go ahead and watch the first lesson that they have called Mod Sketch. You'll get kind of an idea of how Inventor runs, and then we can talk after that. So I hope that you can all hear it. I'd love to get a thumbs up from one of you I'm sharing my sound, and I just want to make sure that works. And then once we get going on that, then yeah, we'll be right back.
In this video, I'm going to show you how to create a mod sketch for a typical 2-light unit. You're going to want to open a standard IPT template. And then we're going to start with creating parameters. These can be used to make configurators and to drive the mod sketch, so that once you've created the mod sketch and then extruded your parts, all you have to do is change some of the parameters and the size of it, it'll all change. So it's best practice to create new named parameters rather than naming parameters that are created automatically by Inventor. So the first thing you're gonna do is click Add Numeric. And the first parameter we'll create is the mod width. We're just going to go with 60 inches. That's pretty typical. Then we're going to do mod height. And we're going to go with 144 inches because that's pretty close to a typical unit. And I'm going to go left mod to DLO, which means the left outermost point of the mod to the inside DLO of our unit. And we're going to create a multi-value list for that. This will make it easier to adjust later. Rather than having to type in manual numbers, you can just have a list, and that way you can also enforce certain sizes and not allow people to enter custom numbers. So we'll right click here, make multi-value. I usually delete the default 1 inch that's there. And then we're going to go 1.375 and 2 points.
Sorry, I'm pausing for a moment. It seems like this is really blurry and I keep waiting for it to pop out of it. But
75 for a typical split and then a jam condition. So we click add and then click OK. Make a new one, go right mod to DLO, and then we can do the same values for our multi-value list that we did for the left mod. Click add and OK. And then sill height. Now our typical sill is 2 1/16, so it's not very often that we have anything different from.
okay, so this is super blurry. I'm gonna hop out of this one, and hopefully we can watch one that is not.
So Chris, I just checked that, and it seems that it's the quality of the recording on YouTube that's showing it kind of blurry, because I'm getting the same quality as I'm viewing it from the link.
Okay.
From that, so not.
So that's odd because I watched it earlier and it was, in fact, not this one today. It was, a couple of days ago, but it was clear at that point. So we'll just watch a different one. I would like to welcome Ed. I see that Ed has joined the meeting, as well as Ron. Well, nice to see you, Ron. And Ed, feel free to jump in. I basically just gave an introduction about the ways that you guys are using this, that you're certainly going to be able to speak to this with a lot more authority than me. So I'm going to just load up basic sketching. We'll watch the video, and then perhaps we could open up to questions because you're here, and you'd be able to answer any questions people may have. Okay, so let's try another one.
Let me ask something, guys, quickly. Would you say that if you record something in this Screencast-O-Matic, is this going to be the fidelity or the clarity all the time, or?
No, I don't believe. I think that it's, I've seen high produced like good quality videos that have come from that. So
Okay, thanks.
okay, so let's try another one.
In this video, I'm going to cover the basics of sketching, extruding in parts. Most of us should know how to do this, but I'm just going to give a quick primer on this so that people understand, and so that we can talk about some of the best practices. So I have extruded 2 verticals and the head glazing adapter. The head has been extruded, but it's going to be in the way of what I'm going to be showing you, so I've turned the visibility off on that. So we're going to sketch and cut a notch in the head glazing adapter for the verticals. So we're going to start a sketch and either type S or click Start Sketch in the upper left-hand corner. So I'm going to type S, select this surface here. The reason I'm selecting this surface is because the back of the adapter is higher than this surface here, and so is the radius here. So if I select here and make my sketch here, then I have to do a symmetrical cut through all to get rid of everything. Whereas if I just start it up here and do through all, it'll start here and cut through. I'm going to draw a 2-point rectangle. I just do right click, select 2-point rectangle. And I'm going to draw my rectangle over here in space because I found that when you do it over the object that you're trying to sketch on, it'll try and connect with points in that object. And then you'll have to delete constraints so that you can get the part or the sketch where you need it. So I like to start them out in space and then use the constraints to constrain them to the geometry that I'm working on. So we're going to use the collinear constraint, and I'm going to select this line here and the end of the extrusion, and then this point, this line here, and this will be the point for the back vertical of the cut. Constrain that there, and then I'm going to use a parameter to control this because we can use it later on the other end of the part. So I'm going to type in 0.375, and that'll give us plenty back to pass the back of the part so that we don't have to come back through and cut out any small pieces. And then I'm going to put a parameter here, and I'm going to go 1.125. The glass plate's an inch, so that gives us an 1/8 of tolerance around the vertical. And then you can either start the extrude command in the sketch by typing E, or you can finish the sketch and then type E, and then the extrude palette comes up. You just select the profile that you're going to extrude and then select the cut function, and then we're going to select through all. On parts that you would sketch and then extrude yourself, not extrusions, it's best to use through all so that if your part changes, it'll always make the cut through all if that's what you intend. If you need something that's controlled, then it's okay to use 2 or give it an exact distance for the extrude or cut. So I'm going to click through all, click OK. So now we've made our notch around the vertical for the head glazing adapter. When you do extrudes, your sketches get turned off. So I'm going to turn this one back on so that we can use the parameters that we used here in the next sketch on the other end of the glazing adapter. I'm just going to repeat the same procedure. So I'm going to type S for sketch, or up in the left-hand corner, start 2D sketch. Select the top of this surface. Draw a 2-point rectangle. Then I'm going to use the collinear constraint. Constrain the end of the part. Constrain the side of the cut to the side of the extrusion. And then the parameters, I'm going to start this parameter here. And when you drop it or click, it gives you the option to fill in that field with a number, or what we're going to do is, this is the end depth of the part. So I'm going to come over to this other one and click on the dimension that we put in there and then hit enter. So if somebody changes this dimension for this cut on this sketch, the same thing will happen inside this sketch, and then the part will adjust automatically. And I'm going to do the same thing for the length of the cut. Come over and click on that dimension and click plus, or click the check sign. Now see if there's a number D405. If you know the number for the parameter that you want to use, you can just type it in. You don't have to go and find the other parameter to click on it. So that's if you can keep track of all those, that's a quick way to do it. Then check the box there. And then I'm going to hit E for extrude in the sketch just to show you how that works. And it brings up the extrude palette. Select the profile, click cut, and then through all, and then click OK. So when you do that, it all happens inside the sketch environment, but as soon as the extrude's done, it checks out, it saves the sketch, and you've done your extrude and your sketch all in the same function. In the next video, I'll show how to make sketch blocks and how to place those.
All right. So, I kind of, Ed, I don't know if you were here at the beginning, but I kind of just went through some of the different things that we've talked about, kind of the process that you guys use, and basically what these different categories were, a little bit more on unit modeling process, iFeatures, and Vault. But at this point, I guess we could open it up to any questions, since you'd be a great answer person for that. So.
One comment that I would have to make about the video we just watched is to actually have more advanced stuff on that now, so that when you're sketching the infills, you can actually connect it so that the glazing adapter adjusts when the infill size changes.
Cool.
So that's further down the road. Yeah, if anybody has any questions, I can answer them.
Can we discuss, well, basically I'm thinking about what happened with the model on Inventor. How do you transfer that information to the shop? I'm assuming it's an assembly drawing, but can we talk a little bit about that, or what do you do?
So you mean for when the parts go to the shop?
I mean, once that you have the model ready on Inventor,
okay,
then what happened there on your process?
So once we have the model ready, you actually, in the videos, I'm working in the IPT environment. So then we convert it to an IAM, an assembly model, and that makes all of those solid bodies into individual part files.
That's this one here, right? This top one.
Yes, yes. Yeah. So then it creates all the part files, and then Inventor actually has DWGs, and we've created title blocks and fab sheets, and you can actually take the part and drop it in the fab sheet so that you can have a fab drawing to give to the shop. We initially tried to really lean on step file creation so that the shop could just use that with the CAM Plus software and have, because it's supposed to be able to recognize 3D notches and things like that, but it's not consistent. And so for now, we have to go back to just using fab drawings. The great thing about the fab drawings with Inventor is that if you go to that part in the part environment and make a modification to it, it updates the fab drawing. So, because there's a direct link. So if you had a part that was just a solid length, it's cut square, and you wanted to put some holes in it, if you put the holes in the model and go back to the fab drawing, they're in the fab drawing. You still have to dimension them or do whatever annotation, but it all shows up. It all automatically updates. Does that answer your question?
Yes, well, thanks for the answer. Yeah, maybe I need to see the video later to just have a clear idea. But for now, it's clear the process to me, what you have. Thank you.
And does it make the mark numbers for you, or you have to assign them yourself?
Right now, we're doing a hybrid approach where we're using the takeoff program to create mark numbers. Then we have to assign them to the parts manually. But we're working with an outside vendor who's writing us a program that is going to, between Vault and Inventor, it's going to look into Vault, see if there's a part exactly like that already. And if there is, it'll assign that mark number to that part. And if the part doesn't exist in Vault yet, it'll assign it a new mark number. But we're having, it's taken a little longer than we thought. So there's some issues with the Vault Inventor interaction that they're trying to figure out.
No, I just hope you don't pay the guy per hour.
It was a contract price. They're losing a lot of money right now.
Can you show the fab sheet from this for using this Inventor part, or can you, if time not permits, can you give us a link or somewhere here on this page?
I can, let's see here.
If we have like enough time, huh? Otherwise, yeah.
Well, can I share my screen? How do I do that?
If you should be towards the bottom of your screen in green, there's a share screen button.
Oh, okay, there it is. Let me know when you can see it.
Yep.
So this is a fab drawing for a fin on a unit, and this is an Inventor part. And you place the part in and you rotate it to the view you want, and then you can literally just if you right click and drag, you can place new views off of this, based off of this view, or these are details, and you can cut details with Inventor. And there's a detail tool you click on, and it asks you where you want it, which view you want to take the detail from, and then it lets you show it where, like what size cut you want, and you can change this from a jagged border to a smooth border. So they place these views in here, and if any, like I said, if any changes occur to the part, these will all get updated. They're all linked to the original part. And there's when we have our process where we convert from the part file to the assembly file, we actually have a process that pushes all the information. Like I don't know if anybody knows what I properties are, but we're filling out all these I properties, which is just a bunch of information about the part. And that actually is what's filling out these fields in this text box. We don't do any of the manual entry on this. This is all information that came directly from the part. The second you drop this part into this page, it auto-populates these with the information it has stored in the part. I don't know, is this what you wanted to see, or?
Oh, great.
So you guys, you're trying to kind of get away from the takeoff program?
We are, yeah. We some of the buildings, we've done this. We do a different process, it seems like, than what's being done in California, and we've done some portions of projects with Inventor and actually preferred it over the takeoff program. So we're just that's our direction we want to go in Mukilteo.
Yeah, great.
Are there any other questions? Any other? All right. So that's really what I wanted you guys to be able to see, is that we have a place for all of this Inventor training stored here for you. Ed, I should probably talk to you about, as you guys do updates to your videos, that maybe we could be in on the loop on that, so that we can make sure that we are getting those same updates. So if anyone does go through these, that we'd be able to update with those.
Yeah.
And then so we don't all have Inventor on our computers too. So if anyone was needing Inventor on your computer, you're able to ask for that and get that installed. I think that that's part of the suite that we have. So if you were going to be trying to use that software for something and wanted to go through this training, you just need to put in a request. So. Okay.
And if there's any questions that you don't feel are answered in the videos, you can contact me or let me know, and I can try and answer any questions people might have.
Yeah.
What version Inventor are you using in your videos?
I think that is 2020 or 2021. We try and update pretty regularly on Inventor, because they're constantly working on it and adding new features and changing how things work. And yeah, so we kind of pay attention to what's changing, and if we see something we really think it's worth updating for, we'll ask for an update.
Mm-hmm. Okay. Ed, I was saying Ed has been super helpful to me as somebody that's not that experienced with it. So, and Ed, as a group, I'd like to say thank you very much for offering your time to anyone who may need that, because, you, at least to me, you sound like an expert. And so appreciate your willingness and time on any future issues that come up.
You're welcome. I really have a lot of fun with Inventor, so I like to help other people have fun with it. So.
Okay. All right. Well, unless there's any other questions, this is, again, a resource for you to watch at any time. So we won't sit here as a group and watch all of these videos, but that'll be it, unless there's any further questions. Okay.
Thanks, Chris, and thanks, Ed. Appreciate it.
Thanks, Ed.
Thank you, Ed.
Thank you.
Good.
Yeah.
Byron!